Happy Wednesday, everybody. I'm sorry I'm not there today. I got a lot of people in my house sick, so I'm home. But you are not, and you're going to get so much done today without me. I expect you to be on your best behavior and be very kind to each other and whoever is in your room as a substitute. Do not let me get any bad reports. You don't want to know what happens if that happens. Okay. But I know you won't. You're amazing. Okay, so we're going to start with the do now, just like always. Do the do now, right now, in Schoology, okay? It should be over here on upcoming, or it will be. That's from the day before, but you'll have today's, okay? Put your answer in there on the do now. Describe a convection current. Draw and label a convection current. Not 100% sure if you can draw, but you can insert a picture if you can't draw it, okay? So try to find a picture of a convection current and get it in there. If you don't know what it is, talk to the people in the room. See if anybody figured it out yesterday. If nobody figured out, use your friend Google and go figure it out. Okay, learning target today. I will learn how the sun provides the energy that drives convection within the atmosphere and oceans, producing wind. We have a few I can statements today. I can describe the transfer of energy, define convection, define air mass, define the role of the sun in convection, describe the cause of wind, describe how ocean currents affect air temperature. Okay, to do this, we have a brand new digital notebook. So you are going to open it in Schoology. It's going to pop up on your upcoming assignments on the bottom because it's not due for a long time, okay? Or you can go find it in your blue folder, but it's definitely on upcoming assignments. Open it. It will look like this. By the way, if at any moment you need to pause this video to give yourself more time to finish something, please do that. You are allowed, okay? Also, I'm trying to get through in 15 minutes because that's as long as this recorder works. All right, the title of the unit is The Role of Oceans and Weather. On slide 2, we have the TEEKs, just like always. You can read those anytime you want. There's 2 big ideas this unit. First, global convection patterns driven by the sun affect local conditions here on Earth. Number 2 is that climactic interactions exist among Earth, the ocean, and weather systems. Okay, so we got convection driven by the sun affecting local things, and climate is affected and it interacts with all these other things, okay? On slide 3, there are 3 essential questions that basically align with the 3 TEEKs for this unit. And I did remember your graph this unit. So you're going to be able to graph your quiz results, and then after you take the test, you're going to come and graph your test results and you're going to compare. And hopefully you improve. Slide 4 is our goal slide. Yes, you have to put a goal in order to get credits for that on the digital notebook. It needs to be specific and measurable, so probably it has a grade attached to it or a completion of something. I will complete my digital notebook on time, or I will get an 80 or better on every quiz. Whatever you want your goal to be, put it in there. Nothing below a 70. All right, on to our first notes slide. Here's the thing. I have a whole presentation slideshow that if I was there, I would show you. That's what this is. You have 100% access to this slideshow in Schoology. You always do, but in case you didn't know, it's in Schoology in the blue Unit 3 materials folder right here where it says 1067 daily slides, convection, blah, blah, blah. Okay? If you click that, you can view my presentation slideshow. You might want to get extra things if you miss it as I'm going over it. Also, I'm going kind of fast. So if you need to go back to it to review anything, you can always do that. Okay, so we're going to go through slide 5 in your digital notebook. Okay? Let's see. Radiation is what we're starting with. Oh my goodness, y'all, my brain blanked. Radiation is the transfer of energy as waves. The Earth receives its energy from the sun. I think you knew that. The sun's energy travels to the Earth in the form of radiation. Conduction is the next type of heat transfer. Okay, so on this slide we have 3 types of heat transfer. Conduction is the transfer of thermal energy from one material to another by direct contact. So you have to touch it. This is why you could not touch the hot plate yesterday. You touch it, you burn. Okay, the last type of heat transfer is convection. So drag that one down onto that last blank right there. Well, third blank. Is the transfer of thermal energy by the movement of a liquid or gas. Convection works when a liquid or gas is unevenly heated. Hot liquids and gases rise. They are less dense and rise, causing convection currents. Hopefully you figured that out yesterday when we did our little experiment, okay? Hot liquids and gases are less dense and they rise. That should make sense because we know that less dense molecules are not as packed together. So they're out here, fluffy clouds rising. The warmer section of the material will rise while the cooler section sinks. Okay, on the bottom of this slide, you're going to use that drawing tool again, and you are going to draw a convection current for me right there. So you would use your scribble. You would draw something going up, like that. But we want it red or blue? Red. So we have red going up, blue going down, and it is going to make kind of a circular pattern. We should get some swirls happening, okay? So that's what you're going to add right there. Draw the convection current right there. Okay, on slide 6, you are going to watch a convection current video from my daily slideshow. It's the one on slide 9. You know what? I'm just going to go ahead and play it. Oh, you know what? That won't work. Oh, yes, it will, because there's no audio. Okay. Here she goes. She's putting green food coloring at the bottom of that gigantic beaker. We're going to fast forward. Okay, there is boiling water in this middle styrofoam cup, and she is putting that underneath the green food coloring. I bet y'all already know what's going to happen. Okay, watch. You're going to write what happened onto that slide in your digital notebook. Don't go too soon though, because as this is moving up, something happens when it gets over to the edges. What does it do when it gets back to the edges? Kind of starts making something that we just talked about. Okay, you have access to that slideshow if you want to watch it again or watch it more extensively. What you need to do though is fill in what did you observe on this blue outline box. And then why do you think that happened in the gray box? Pause, do it right now. Next, we're going to talk about why air moves. So, do this with me. You're going to fill in the blanks, and we're going to get hopefully all the way through this. Warm air is less dense and rises, while cool air is denser and sinks. When the warm air rises and the cool air sinks, convection currents are created. Wind is the moving of air, and it is created by differences in air pressure. You don't have anything to drag, but that's super important. Differences in air pressure. The differences in air pressure are caused by the unequal heating of the earth. The greater the differences in air pressure, the faster the wind moves. We got different types of wind. Two main types, global winds and local winds. Both types of winds are caused by unequal heating of the Earth's surface and by pressure differences. Okay, so you've probably heard of high pressure and low pressure. With weather, pressure differences cause us to have wind. Moving on, slide 8 in your digital notebook. The Coriolis effect. This is a cool thing that happens. The movement of wind is affected by the rotation of the earth. If I had my globe, every single one of you knows that I would be spinning it. Remember, rotation is the spinning motion. Okay? Because of this, winds do not blow directly north or south. The Coriolis effect causes the winds to change direction. Because of the Coriolis effect, winds in the northern hemisphere curve towards the right, while winds in the southern hemisphere curve towards the left. Looking at a map is what that means. Okay, pause if you need to pause. Go fill in that slide in your digital notebook. Slide 9, currents in the ocean. So first we talked about the air, movement of air. Now we're talking about water, movement of water in the ocean. Okay, so I think you remember this, but the sun also provides the energy that drives convection in the ocean and produces ocean currents. There are two main types of ocean currents: surface currents and deep currents. Surface and deep currents interact and trade places. Warm ocean currents originate near the, what do you think? You got some options over here. I bet you know. If it's warm, they originate near the equator, and they move towards the poles or higher latitudes. Warm air over the ocean brings warm temperature to the lands. What's happening right there? Oh, the ocean currents warm the air and bring warm temperatures to the land. Cold ocean currents originate near the poles or higher latitudes and move towards the tropics or lower latitudes. So they can decrease air temperatures and bring cooler temperatures to the land. Okay, pause. If you didn't get all of those blanks, you can go back and forth and look at them. On slide 10, you need to answer these 3 essential questions. What provides the energy that drives convection currents in the atmosphere? Answer here in a complete sentence. Middle one, what causes wind in the Earth's atmosphere? That does not have to be a complete sentence. And the red one, how can ocean currents affect air temperature along the coast? That should also be in a complete sentence. So you have sentences on the edges, probably just a word in the middle. All right. Now you are going to do a surface currents activity that is printed out for you to do. Okay? Follow the directions on it and use this picture to help you put in